Tolong ni kelihatan. Buat apa? Tuan tu dah penat kamu, tu penat. Nak seorang ni pula. Ada makan lagi. Ya, jadi nampak mu tadi. Main apa? Dia semayin. Okey lah jam kau ada jam kan. Ya, nanti itu dia tahu. Tolong tak boleh. Hi everyone, shall we start? Yeah. Alright, give me a few minutes. Alright, sorry, yeah. So there's some things that I need to settle with my sons. Okay, so we are supposed to start at the exploratory data analytics, right? Okay, exploratory data analysis. Huh? Right. So okay, we have completed the hands-on number one. Okay, so the data that you have checked just now is now ready for the data analysis. Okay, so that means we have prepared the data for exploratory data analysis, and then let's see what are the items in this exploratory data analysis. Okay, so the objective of this EDA is actually to understand what is the structure of the data that we have, and we need to check about the patterns, uh, or is there any existence of anomalies or relationship between variables, right? We also need to summarize what is the main characteristic of the data that might be contribute to the problems that we plan to solve, right? So this will help the top management to decide important decisions, and it will guide to select appropriate models and algorithms so that we can have very good quality data. So there are two types of data visualizations analysis. One is the univariate analysis. Under this univariate analysis, we try to understand the characteristics of individual variables in the data set based on graphical technique, or we can use non-graphical technique. So graphical technique means that we choose suitable statistical representations. Okay, for instance, we try to illustrate the histogram for the data, um, so that we can see if let's say if we have two categorical variables, and then each variables has frequency or maybe relative frequency, so we can see the difference or compare between those two categorical variables based on their frequency. So we use histogram, right? Or other types of statistical representation such as the box plot, or also we call as box and whisker plot. It can be bar charts. We can have pie charts, and then we can have OGIF and so on, right? So there are lots of statistical representations. Okay, for this non-graphical technique, if we want to investigate a single variable, so we can investigate or conduct numerical measurements based on the central tendency. That means we try to evaluate the mean or the average, and then we can find out measure of variability based on the variance of or the standard deviations value. Okay, under second types of data visualizations analysis, which is multivariate. Under this analysis, this method try to find out what is the possible relationship between two or more variables, right? So let's say if we have two variables, so we can check or conduct correlations analysis, and then we can continue further with regressions or any other methods that is suitable. Okay, similar to univariates, we can conduct graphical or non-graphical technique. But for graphical technique, if we want to investigate two variables, so we can use scatter plot, and we can apply conditional box plots, line chart, heat map, and other statistical representation. For non-graphical method, we can use pivot table, correlations analysis, or we can conduct hypothesis testing such as t-test, and also we can apply analysis of variance that we call as the ANOVA. Right. I will review some of the common visualizations, right? We will see after this how to do these visualizations in the Python, right? One is pie chart or donut chart. Okay, the figures that we have on the right now is the pie chart. So this figure illustrates the top 5 countries with most deaths by COVID, right? So when we look in this pie chart, you can see that all the statistical value is represented in percentage, right? This is percentage. Okay, so different groups, which is the country, is being illustrated or differentiated based on different colors. And if we sum up with this all percentages value, it will be equal to 100%. So for this pie chart, only illustrate or we can find out the proportions for certain categorical variable, right? But it's not in depth. So it will be helpful to observe if these proportions of classes of response variable is balanced or not. Okay, so we can see here from this pie chart, United States is the most uh, countries with higher deaths, right, by COVID. Okay, so the coding in these Pythons, right? See, this is the one, right? The item that we see, let's say we have categorical variables that we want to illustrate in the pie chart. Let's say it is the department, right? Okay, so it is data frame, right? So the data frame, so what is the library file that you should include is the pandas, right? So you must import pandas as PD, and then we proceed with this dot value counts. uh, in this pie chart, there is some visualizations that we have to use it, which is based on the PLT, right? This is based on library type of matplotlib, right? Okay, so this PLT will belongs to this matplotlib. Okay, so in the um, command prompt for this pie charts will be included as this part, right? Department counts, this is the previously we declare at the first row. Okay, so you can decide what is the kinds or what is the type of visualizations that you want to do here. So let's say this is the pie chart, so you can use kind equal to pie. So you can change the pie to other visualizations such as the histogram. Of course, this is not the only way lah to illustrate the pie chart, alright? Okay, and then you can include the titles, right? um, in this second type, similar to the pie chart, okay, is the donut chart. The difference here, this donut chart has a circle in between, right? Okay, so in terms of numerical measurement, still lies on the percentage value. So in this donut chart, it illustrates the distributions of employees by the department. So we have 4 departments, right? Whereby finance indicated the highest percentage. Okay, so in terms of the coding in the Pythons, right? First one, you have to create the pie chart because the basic of donut chart still lies on the um, pie chart, right? Okay, so we need to create the pie chart first, and then after that, so we need to include the white circle. Okay, so this is actually the step to include the white circle, whereby this PLT dot circle is the uh, white circle at the center, right? That makes the shape. So the shape, let's say the middle one, the color that you want to choose is white, so the center will be in white color, right? So other things that you can include is the title, and then at the end, then we can see whether the layout will to be shown later on will be in the type layout, and then you can display it using plt.show. Right, next visualization is the histogram. Okay, so this histogram is used to visualize the distributions of a single variable. Okay, but actually the histogram um, immediately showcase how this single variable distribution is Q. All we can find if we compare the mean value, right, with other attributes such as the median and the mode. Okay, so how is the distributions, whether it is skewed to the left or skewed to the right. Okay, so um, the middle figures actually is symmetry histogram. Okay, this is a symmetry histogram. So that means the mean, median, and the mode is lies on at the center of this data. Right. If we have left skewed means that we have more weightage on the right, right? And then if it's right skewed, it means that we have more weightage on the left side. Okay, so we'll go through this left skewed and right skewed in terms of the computations after this. Okay, so the coding in the Pythons, how to include is um, similar to this pie chart. You need to change this kind to the histogram using his HIST. Okay, so this bintan means that how big is this the bar that you want to include here, right? So this is around with tens, bins is equal to 10. So if you change 20, maybe the size um, or this one bar will be having a bigger region, right? And then you can include any title in the histogram that you want to use there, and then include the label for x and y axis, right? What is the variable for that one? And then you can finally you can show the graph for this histogram. Okay, next one is bar graph. This is quite similar to the histogram, except that in the histogram, um, we can't compare between certain groups, right? For this bar graph, we can have bar graph for a single variable instead, okay? But we can also have a bar graph that compare between certain group, okay? So if we can see here on the figure on the right side here, we have bar graph where compare basically based on the days and the total bill, right? So uh, we have two groups whether we have two groups, that means number of smoker that contributes that there is a smoker, which is uh, in the color of blue, and then non-smoker in the orange color. So we compare these two groups of smoker and look at their total bill. So this bar graph one of the method that we can rank the data according to certain categories. Okay, so you not only having two groups, but we can have more than that. Okay, so this is an example in vertical way, but of course you can have in horizontal way. Okay, so not realize only based on this type. Okay, in terms of the coding in Python, right? It's quite similar to the histogram. Okay, you must have variables that you want to check on x-axis, right? Then we have followed by value underscore counts, and then the kinds of the graph will be bar type, and then in this case you can include the color, right? Okay, in the previous figure, right, there's no coding for the color, but actually you can change. If you didn't include the color in the coding, by default the color will be blue, right? So if you include this color green, so the color will be changed according to the one that's specified. Okay, and then followed by your title of the figure. So actually there is a title here, right? Okay, there is a title here, and then the label at the x-axis, which is the department, right? And then label for y-axis, which is the count. Then finally we have plt.show. We can have other methods, but I just show what are the simple commands in this bar graph illustration. Okay, next is the box plot. Okay, so in this box plot is actually one of the visualization to summarize the variable, the distribution of the variable. So in this figure of box plot, we can see the different types of sepal and length, right? Okay, so there's a meaning between this figure, between the blue, orange, and green color. So we'll see after this the explanations. In terms of the coding, okay, in this box plot, we need to use df.boxplot and then followed by the column of salary, right? And then include the title, and then the supplement title, and also the x and y label, and finally we have to display the figure or the representations. Okay, so in this box plot, okay, in the previous figure, box plot illustrate about the medians and also the lower and upper quartile. So there is a meaning of this value in the box plot. So for this median, median value in the box plot means the median value of data set where 50% of the data, okay, from all samples, from all number of data that we have is less than the median, and 50% of the data is higher than the median. So in this box plot we can find out the upper quartile. So upper quartile means 75 percentile of the data set is less than the upper quartile, and 25% of the data set is higher than upper quartile. Okay, for lower quartile, 25% of data set is less than the lower quartile, and 75% is higher than lower quartile. In this box plot also there is interquartile range, right? So this interquartile range we can compute by finding the difference between upper quartile and also lower quartile. And through this box plot method we can find out if there is any outliers, right? Outliers means that the data is suddenly out of range. Okay, so it can be any value above the maximum or below the minimum, so we call that one as the outlier. Okay, next representations we have scatter plot. Okay, so on the graph on the right figure is the example of scatter plot. You can see that it is noted by these kinds of small bubble on the graph. This scatter plot is used to visualize the relationship between two variables, right? We have x and y. So x is the independent variable, y is the dependent variables. So from this scatter plot we can find out quickly. So what is the correlations? Okay, for instance, if you have some kinds of data that is looks like the bubble graph is on increasing order, so we might expect that there is an correlations or relationship between the variables, right? So in terms of the coding, right, so we have to replace the kind to this scatter. Okay, in this kind replace it on the previous coding for your histogram, or it can be on the bar graph. Replace it with the scatter based on the scatter plot, and then you can include the color, right? So on the right side now I have changed the color to orange. Okay, I want to show that the data shown distributed as the orange color, and then I can include the age and the salary, that is for x and y axis, and then I can include additional title that this is the scatter plot for the age versus the salary, right? So either items will be similar methods. Okay, next one is the heat map, right? So this is an example of the heat map. So through this heat map, what we can see is the relationship between two variables. And in this heat map, we can see on the right, we have some kinds of value, right? So we can find out the degree of correlation between two variables. In this box, you can see there is a color, black color, and then some kinds of red color, right? Some kinds of orange color. Okay, so the difference here is we can find out all variables attributes, and this correlation will give us whether if there is an existing of relationship, then you can proceed with you can proceed with regression analysis method. Okay, from these correlations, let's say if the variables have a strong relationship, either positive or negative relationship, so you can proceed with regression analysis. Okay, so the coding is Python will be okay, because there is a correlations, right? So you must import this library file, which is as the cbond. Import cbond as SNS. Okay, so this cbonds I have explained before this in the Python parts, right? Cbond. So this is one of the library file. So in this cbond, because we want to include some kinds of correlation based on the heat map. Okay, then this heat map will be depends on the SNS, which belongs to the cbond. Okay, so first one we need to calculate the correlation. Okay, we cannot start directly with the visualization, so we have to find out what is the correlation. So if you have more than two variables, right? So you have to add something here. In this example, we have only two variables, which is the age and the salary. So we evaluate the correlations to the data frame between the variable age and salary. And then we can just proceed with dot CORR. So this means the correlations. Okay, core in short form. And then we can set what is the size of the heat map that you want to design, right? If you want to have a square figure for that heat map, so you can just change these dimensions, right? Okay, and then it will be followed by the correlations. Then another true, we can include the color, right, for the heat map. Okay, so in this heat map will be defined by the C map color maps. That means we want color in the heat map as the cool warm. And then we have V minimum and V maximum. By default, it will be -1 and 1. We don't have other values because uh, the range for the correlation will be between these two. Okay, you cannot have other value that is not in this within this range. Okay, if let's say your correlations is 2, so you know that that is wrong because correlation value must lies between -1 to 1 only. So 2 it is will not be accepted. Right? Okay, so on the right figure, you can see here in this correlation heat map, right? We have two variables, and so that means we have these regions of your age. So it show that this is one. So this one means that age and the salary, right? Age and the salary. Okay, sorry. This rate is age and the age, right? We see here age and age. Okay. So that one means that is this that separate between age and the salary. Okay. We have this one 0.018. Okay, 0.018 actually is a weak values because okay, in these correlations, right, we have now uh, where this one is -1, then the highest one is 1. Okay, the middle one is 0, right? uh so 0.018 is actually close to this 0, right? Close to 0. Alright, so we can call that this salary and age has a weak positive correlation because this value is positive. But if we find out that, let's say the value displayed that is 0.8. Okay, so let's say 0.8 somewhere here. Okay, 0.8 somewhere here. So the 0.8 is uh, going to 1 is actually. So it is a positive correlation. Okay, so you can, if we have strong correlations, that means either it is close to 1, or maybe we can have on the negative scaling value, maybe -0.9. So that is close to -1. So we can count that one as strong negative correlation. For this case of 0.8, right, this is a positive correlation and going towards to 1. So we can call this is a positive correlation. There is correlation between this variable. So from this correlation, we can proceed further with the regression analysis. All right. Okay, so compared to the previous visualizations that I have discussed, so we have histogram and the scatter plot, box plot, and the heat map. Okay, so you have to take note that histogram can be used for single variable distributions, but in different situations we can have histogram on different cases. Scatter plot is used for pairwise relationship. Okay, either two variables or more than that. We use box plot to find the spread and outliers in that distributions, and then we use heat map for the matrix data or correlation. Okay, so because there is a lot of statistical data that we have, right, nowadays. So which visualizations or statistical representation that we should use, right? Okay, so first of all, we need to find out what would you like to show. Either you want to compare, you want to find out the distributions, or you want to see the compositions, or you want to see the relationship, right? Okay, so this mind map will guides. Okay, in terms of comparisons, right? Okay, in terms of comparison, you need to decide whether it is among of the item, or it can be over the times, right? If it's over the time, we want to compare over the time, so you need to consider the time based on the periods or few periods, right? The duration is long or maybe on certain few periods. If it many periods, so you can use circular array chart like this one, or you can use line chart if it's no cyclical data. Okay, no cycle lah. This cyclical means that it has a cycle. Non-cyclical data means that it does not relate to the cycle. Okay, so we have, if it's cycle type, you can use circular array chart. Otherwise you can use line chart. If the comparisons consist of few periods over time, and then you can consider single or few categories based on the bar graph or bar chart. If it many categories, so you can use line graph. Right. If the comparison is among items, where if it's involved two variables per item, so you can have variable with chart. If it's only one variable, you might be considered categories. Alright. You can use table to see the comparison, or you can use bar chart for the few categories. Okay. In terms of distribution, right? Okay. Distribution also you need to investigate in your data set. Is it involve single variable or more than one variable? Okay, if you want to see distribution for single variable, there are a few methods. Whether you can use bar graph or histogram, you can use the line histogram. Okay, otherwise if it's not single variable, you can use scatter plot. Okay, for the compositions, if it's static, you can use pie chart, waterfall, the stack graph, or it can be the tree map. Okay, if the composition change over time for few periods, right? So you can use stack graph, uh, or stack bar graph, or it can be stack 100% area chart or stack area charts. Okay, if it's involved many periods. Okay, for the relationship, you can investigate based on the scatter plot, or you can have bubble graph, something like this one. So that this is the main guidelines lah. In the data visualizations, you need to find out, are you supposed to do comparisons, or you only need to investigate the distributions, or uh, you want to investigate in terms of the compositions, or you want to see or find out what is the relationship between the variables. Alright, okay, so we will start hands-on number 2, right? Okay, so um, we will use same data, sales data, sorry, sales data. Okay, we will use a different data set. The file that you are supposed to use now for this hands-on is sales data. Okay, so hands-on number 1, we have samples data, right? So this time we want to see sales data. We will use the sales data, the CSV. Alright, so this is the guideline. Okay, so in this hands-on number 2, you will use several library, because now we will start with the data visualization. So many will use Matplot library and also Seaborn. Okay, so the first step is you need to load the data set. Okay, so I believe that you are familiar already, because we done hands-on number 1, right? Okay, so load the data set and you check, is there any missing items, and so on, right? So that is the first step. Okay, once you confirm that all data is ready, right, then we will start uh, plotting the graph. Okay, so you can start now. You can copy and paste the previous hands-on number 1. Okay, but this time you need to use sales underscore data dot csv. Okay. Okay, so you can try now. Okay, refer back to your Jupyter lab. Okay, you can refer to Jupyter lab and check your sales data. Okay, make sure sales data is in the folder, right? Okay. Okay, hands-on number 2, you have to create new files and then give the names of the file as hands-on number 2. Okay, is anyone having problem? You can let me know. Please let me know. Alright, so you can create new files because this is new hands-on, right? So create new file. Okay, then see this hands-on number 1. Right, so you can copy this code, do some editing. Okay, no need to type from scratch lah. Alright, this time you want to see sales data. So sales data is here. Okay, this is detail sales underscore data. Sales underscore data. Give this name. So number 2. Okay, so you can repeat a similar step in hands-on number 1, right? So check the info through this df to info, then check the header of the data, and then see if there's any item. Then you can check is there any empty data in the data sets using this df.isNow. Okay, then you can share the result. You can update what is your result. Okay, so let me know what is your result from the earlier stage. Do you need any cleaning? You need to include any cleaning. You have to do any duplications or remove missing values. Okay, let me know what is your result from the earlier stage. Okay, anyone stuck? Let me know. You have any problem? Alright, so is it all of you done the preparation, data preparations? Or need uh, more time? You need more time? Do you need more time? Or I can proceed? Kawaiche, you done already, is it? You have done, Kawaichen. You Zuanhu, you have problem or not now for the hands-on number 2? All right. Okay, so since we have verified this data for this sales data, all right, then we check the infos, okay, about the number of uh, items in this data set based on the column of month, sales, advertising, okay, then the customer age, right, so all are complete, and then we confirm it with this the f dot is now, and then we display the data all of them, right, using this coding. Then now we will start the data visualizations, right. All right, so our data set is now ready. Okay, so we will do some uh, graph plottings, right. Okay, so this is a specific task for this hands-on 2A. Okay, first one, we want to see the distributions of the sales using the histogram. Okay, so we use histogram, and then we will use the scatter plot to find out what is the relationship between the variables, right. And then we will try other visualizations. Okay, so you can consider the codings from trial. Okay, this trial, right. Okay, or you can refer to the pie charts values. Okay, this one I want you to change some important items, so and then you can try it. Here the task is from histogram, right. Okay, so you can refer to the slides, actually it's the same one. This histogram is uh about the the yeah, so this is coding, not the same one, this part you have to change it. Yeah. Okay, you can copy from this part, except that you need to change your items here. This is not age, because we have different um data set now, not as the age, okay. Okay, so we need to see what is the distributions for the sales, right. Okay, distribution of the sales, right. So what changes we should make in this coding? Okay, what changes we should make in this coding? So I highlight for you. Now my question is what changes we should make in this coding? Sales and month. Which one is the month? Sales and month. Right. So which one is the X and Y? Okay, sales and the month. So which one is the X and Y? Right. So Y is actually is the dependent variable, okay, or the variable that you want to predict. X is the independent variable. Okay, so which variable will be X and which one will be Y? Sales X, month Y. Sales Y, month X. Alright. Okay, so which one we should decide? So basically, X is the variable that we cannot control, right? Okay, X is the variable that we cannot control. So if in these issues the data set is about sales data set, so the sales data set is recorded based on the month, and then the advertising and also the age, customer age, right? Okay, so of course the most important part we want to know is about the sales, right? So this month we cannot control it, so this X actually is your month, right? The sales is your Y. Okay. Okay, so you can change this part. See here. All right, change this part to the months, and then you can just replace it sales distributions. This is the month. This, yeah, this is the months. Okay, so you can change it if you want to find out other relationship, maybe the advertisings, or maybe with the customer age, you can do that one also. Okay, so I want you to try, see if you can share some things might be important, so you can inform me, right? Okay, so this time you have to try it by your own, okay, so please update me what's your result. All right, you got any error? Is anyone having error on your workspace? You have error? If you have error, you just let me know. Right, so the histogram just now, right? You can have something like the X as the sales also, right? You can have X as the sales, but the Y will not be um, the month, right? The Y is actually will show you the frequency of the sales, right? And then you can investigate another histogram for the month, okay? Because in this histogram, right, it will be stand alone for a uni variable, means that as a single variable. So in this histogram, right, you only can see a single variables distributions. Okay. Okay, so let me know if you have problems. Got error with the month. Alright. Can you share your screen, Ka Wai Chen? Can you share your screen? You mind to share your screen now? Yeah, I want to see what types of error. You know, numeric. Okay. Have you import matplotlib, because you have you have. All right. So okay, got error with the months. Okay, because the issues, right, in your okay, I would suggest you to change that month to sales, right? X label is sales. Okay, change that one. X label is sales. Y label is frequency. Mm. Histogram only can do for one single variables. Okay. Alright, it's okay. I will share you some coding that I've tried. I will post it in the chat section. Okay, can try. You can try that one. Okay. Okay, okay. You still got error or not with the coding I posted about the histogram? That is one example. You can do for others also. Can let me know if you start? Let me know. All right, no error. Okay, so no error, right? Okay, so the errors is actually is about your Y label lah. It should be frequency, yeah. Okay, then try others. Um, okay, you can try others. All right, okay. I have no error, right? Okay. Okay. So in this trial, right? Because this trials actually work for hands-on number one, right? Uh, if you refer back to hands-on number one, um, I will just demonstrate lah. Right. For this hands-on number one, we done already with the data preparations. We do some data cleaning. Okay, so if we see here, see, okay, we have these attributes in terms of your name, age, and department, also the salary. So we can see, let's say we want to investigate lah, is there any relationship between the age and the salary, or maybe the departments or also with the salary. Okay, because this name is categorical variables, correct? Name and the department also categoricals, right? So from these trial ones, actually I provide some distributions of the data. First one, I have this pie chart, right? This pie chart, this is for hands-on number one. So you can copy, and this is just an example, and you can paste it here. Okay, you need to make sure, so this department is your attribute. Okay, this is your attribute same name. Okay, you must use the same name Alright, so this is just an assignment. I want to see the distributions for the departments, and I want to choose a pie chart because I want to see uh which groups in, okay, has maybe contribute to the highest percentage, right? Between which department. Right, so can just run it. Okay, did I miss import? Okay, I haven't included the import library. Just include here. Just include here. this is the outcome. Okay, because just now uh, we haven't used this matplot library, so we need to use or import this library. Okay, because you see that this is a PLT coding, right? So this code will be under this library, so that's why we need to import this library. Okay, so from this pie chart, right, you can see among these four departments, which one contribute to the highest one. Okay, you can see that this is the finance. So there's no in-depth analysis. I just want to see the distributions, right? Alright, so you can try with donut chart lah. Actually the same thing donut chart. It's actually same numerical measurement. Still finance is 34%, right? Except that it has different visualizations. So do you think this donut chart is more interesting than pie chart? So you can use this donut chart, okay, in your data visualizations. Now for the histogram, right? Okay, so for this histogram, this x-axis will be one of the variable that you want to investigate, and usually for this histogram, the y-axis will be your frequency, right? So if you want to investigate relationship, then you can use x and y, independent and dependent variable. But for this histogram, no need to use that one because this is histogram just want to see at first levels of or the surface where we want to see at that variable which one will be most contributed one. Okay, right, so from this graph, right, can see that this age has maybe peak or the highest one at the frequency 8, right? So just for instance so you can copy and try and copy this code and paste it to your hands-on number one right? Okay, for the bar chart, okay, bar chart, let's say you want to investigate in terms of the department, so you can evaluate right, this kind of example, right? The x-axis is the department and the y-axis is the frequency, or we can label it as the count, right? Then you got this result. Let's say just now we have this histogram in blue color, right? Because I didn't include the color here. Okay, so this time you can include this color as green, or you can change to other colors. Right, and then we have box plot, salary distributions. Okay, so what is the interest in the data of sample data? Okay, between your salary departments and the age and so on. So we want to see because the name might not be significant for us to investigate, right? We have the name, right, and also for uh, specific age, maybe we can have it. But first, let's investigate between the department and also the salary. So box plot, we set what are the variables that you want to investigate. Okay, let's say you want to find out the salary distributions, and then you need to use this box plot, right? Okay. Um, and then you have these kinds of outcomes. So then we compare. So what is the meaning? All right. Okay. In terms of the comparisons. um, in terms of the comparison, because we haven't reached at this box plot, right? There is a difference between the mean median modes, right? Okay, but that one is up to the we reach at that part of statistical concept, right? Okay, for scatter plot. Okay, scatter plot, yes, you can use the x and y. So for your case, right, you can copy this part for the scatter plot, and then you change your x and y. What is your x variable? Okay, what is your y variable? And then change the title. Okay, so maybe you can try this and then do that one on your hands-on number 2. Okay. Okay, so this one is the distribution for the sales, right? Okay, so from this one histogram, we got this is the lowest one lah. So we need to investigate what happened to this sales. Why this suddenly drop, for instance at which part? Okay, so you can proceed with the scatter plot. You can try. You can try, you can proceed now. Yeah, okay, let me know if you got error. Okay, you can try. Let me please update, huh? Please update with me. Okay, so what types of data visualizations that you use? Anyone can summarize? Maybe you can inform. Okay, can use what? Histogram. Any other data type you try with? Anyone would like to share? What are the visualizations that you use for the second data? mainly you can use histograms lah, right? Okay, if you want to use let's say um you want to see distributions of the sales, advertisings, and the customer age, right? Okay, uh sales, advertising, the customer, sorry, uh the age, for example, the age, so you can use actually histogram plots, but there is some item that you need to contribute lah. First one is you use histogram, one histogram for distribution of the sales, second histogram as distributions of the advertising, okay, third histogram for distributions of the customer age, then you can show it, right? Okay, so that is the meaning. Okay, any questions? Shall we proceed to the next part? Yeah, what do you want to ask? Yes, Isabella, right? Okay, so series sample. This one you do for what, yeah? Resample, right? Wait, resamples. That one is uh we haven't reached at that part, right? Resample is it? Let's see, we haven't reached at that part yet. We haven't reached at the slide. That one is trend analysis. I haven't start at that slide yet. Alright. Okay. Probably continues is that one. Okay, for the first CSV, right? Can see this is the scatter plot. First CSV, okay, not the second file. This is CSV we use for hands-on number one. Okay, so there's an example for scatter plot, right? This is scatter plot. So this scatter plot, right, you have to make sure this is numerical, this is numerical. Cannot have categorical. Okay, then put the title, then this is the graph. Right, so this scatter plot show the distributions, right, of your two variables between the age and the salary. And then let's find out what is the heat map. Okay, there are two ways that you can use in the heat map. If you can recognize what is the variable that you want to investigate, that means you already identify which variable from your data set. Oh, you already identify this is the two variables that you want to investigate. Okay, if you are not sure which variables, so then you can use heat map for all variables. Okay, if you want to investigate the heat map of all variables, right, this is the way. Okay, this is the way. um in this heat map, right, because your department is in categorical variables, right? Department is a categorical or the qualitative data, correct? So this qualitative data you have to convert into the numeric codes. Otherwise, you cannot find out lah what is the correlations. So this is the way how we convert categorical variable to the numeric codes in order to find out what is the correlations lah, right? So we want to visualize the heat map. Okay, so this is the code. DF department equal to DF department. This is because department is a categorical, right? Then dot S type category to this dot cat dot codes, right? You have to convert the first, otherwise you cannot evaluate. But this method only applicable for categorical or qualitative variable, right? Okay, and then you can proceed with the correlations. So evaluates using df.core, and then you can set the heat map, okay, through this s and s dot heat map. Okay, so see, yeah, this is a specific one, so you have to import this library for this s and s. All right, and then the heat map, and then set what is the range. It should be from -1 to 1. This is the valid value for the correlations, no other values, and then you can show it. So in this case, we have basically three variables, correct? Salary, department, and age. So since the department, we have converted it to the numeric codes, right? Okay, so what we can find out here, correlations between age and the department, 0.024, right? Age and the department. Okay, and then the correlation between age and the salary is 0.018, right? Okay, so this, okay, but we have the results here, right? Salary between the department, correct? Okay, there's some value. This color is quite it's having quite strong, right? Quite strong, because this is the color. You can see this color is around between 0.25 right, to 0.5. That this is the color, so you can further investigate, right? Maybe we proceed with the regressions equation and so on. Okay. Okay, there is an additional if you want to plot the data, but if we identify what is the data, you can use line graph, right, to show it. But for this first CSV file on the sample underscore data dot CSV, you can try or play around with these kinds of examples of these data visualizations. Okay, all right. Uh, okay. Now I will share my screen for the slide. Okay, I will start at this patterns, because the correlation already explains. Okay, there is patterns in the data. One of the method is trend analysis, right? So this trend analysis, through this method, we can identify the pattern to whatever types of the trend of the data. Okay, so there is several types. Mainly, these are the four groups. First one is the secular trends. Uh, this is an example of that comes from the population growth. This secular trend actually is a long-term movements in the data. Might be interesting or might be significant. Okay, when we look at these patterns. Second one is the cyclical trends, right? And then this trend is like a cycle, right? So on the previous figure, when to use that so different types of visualization depends on the group of data or types of data that we want to investigate. So this cyclical trends is the pattern that occur over a cycle, such as the business cycles. Okay, third type is the seasonal trends that this is a pattern that repeat at regular intervals, such as holiday sales. Okay, and then irregular, whereby it is unpredictable, and random variation, such as we can see this in the specific case, such as natural disaster. Right, so we will try next hands-on 2B. Sales data. Actually, the coding is actually already done. Trend analysis. You can open in your Jupyter Lab. This folder is the file that you are supposed to open is trend analysis. Okay, right? You have it, right? You have it. Okay, trend analysis. The file that is sales data pattern.csv. Okay, so looks similar, but it is a different files. We have sales data file. We have sales data pattern. Okay, sales data pattern. Okay, so as usual, you can repeat the step until you are familiar or master the step. Right, import the pandas and then treat the data. Okay. Um, in this case, in the sales data, you can see the df, the info, and the null codes. Right, it's null one. Uh, uh, you can use all the ilog to see all the variables, right? There is one variable that which is the date. Okay, so data pattern is here. Okay, this is the CSV file, right? The dates, the sales, the region, and the category of the product. So this data record based on the region and also category. The sales distributions is stated here, and then the date is recorded. Let's see the format, is it standardized or not? Right, we don't have any issues with the data. Looks like it's okay, so there's no need for us to do data cleaning, right? No items, no data is missing, right? All are in correct formats and so on. Okay, so the date is categorical type also for the region, right? Okay, also for the product category. So in this trend analysis, let's say we want to convert the date to the date time so that we can have um, uh, some kinds of dates display, something like this one, right? Okay, so after reading the data sets, let's try to convert the date column to the date time using these commands, right? Okay, so these dates will be standardized based on the to underscore date time. So we're just having this one as date, right? And then we will set that this column as the index, right? Set as the index, and then we need to set it is in paste true, and then try to display the first few rows of data frame. So usually it will be displayed the first five. Okay, first five in the data, something like this one. Okay, so in this trend analysis, because we will try with some kinds of uh, SNS, right? SNS, and then we have figure show, because this one we start from a new notebook. Okay, so we need to import the matplotlib, and also we have monthly sales. Okay, we need to resample the data to monthly frequency, right? uh, this resample looks like we want to group the data to monthly frequency and calculate the sum of the sales, right? Because here just now we set the dates, right? So the date we want to make sure that it is been sorted based on the specific month. Okay, so that we can group them. So this is the process that we do resample the data to monthly frequency. Okay, so this is an important method lah, right? So to do the resample, we include this which group, which attributes or which variable that you want to do the resample. In this case, uh, we want to do for the sales, and we want to group as the monthly sales, and then resample it as m, and then dot sum. Okay, so we will use this monthly sales after this in the graph, right? Okay, so first one, we need to make sure what is the size of the figure that we want to show after this, and then the label. Okay, for which variable it is for the monthly sales, and then uh, the title, and then followed by the label for x and y axis, right? And then you can see the legends. Okay. So then because you see, this legend, right, is empty, correct? So we will set the compiler to set which one is the best locations of these kinds of legends lah for this time. And then see, this is the difference. Okay, so what we can find out here, what is the pattern of the trends here? What is the pattern of the trend? We have four types just now in the guideline. There are four types. What do you think about this pattern? What do you think about this pattern? Irregular. Not sure, is it irregular? Okay, see the identifiers. Is it irregular? Looks like there is a pattern. Is it secular or cyclical trends or seasonal? Seasonal means pattern that repeat at regular intervals. Right, so looks like seasonal. So because you see, we see at the peak here, this one peak at the top peaks, right? Looks like if this is the month, right, maybe we can say it is maybe between what maybe December or until January. Okay, how about this one? See, this is at the peak, right? This looks like a January one. How about this one? Okay, this is looks like a January. Okay, and this is looks like a January also. There is some kinds of interval lah, either between November to January and something like that. Okay, so that one is we can expect lah, that kinds of situation might occur in the future, right? So due to this one, we can say that this is close to the seasonal trends. Okay, close to the seasonal trends. All right. Okay, so we done this. Okay, so this hands-on to be, because I have prepared this hands-on for you, so you can see and try to understand after these explanations, right? So this is hands-on. Sorry, this is hands-on to be. Sorry, my mistakes. Okay, so this is actually the explanations that I showed to you based on the programs. Okay, so now we will start this statistical concept. Okay, basic statistical concept. The one that we consider in this for today's workshop will be basic statistic. First one we'll start with measures of central tendency, which is the mean, median, and mode, and then we will see measures of variability in terms of standard deviations and also variance. Right, so you have been familiar with these computations, right? This is a basic formula for the raw data computations of the means, right? So the means, or we can call that as the average of the data set. And then we have the median, so meaning here the median value of the data when it's sorted, and mode means that the most frequently occurring value. But please take note that some on different situation, we might have a case that the mode does not exist, right? That means there is no mode. All right. In terms of method to compute, so let's say we have very simple or very short data here. Okay, very few data. We have 1, 2, 3, 4, 5, 6, 7, 8. So to compute this, the mean we just use NP. This is numpy. NP refer to the numpy. So in order to compute this mean, you must import that numpy library, right? And then we have this mean value as 4.714, and so on. Okay, then for the median, you can use np.median. And then for the modes, this is special one. We have to use uh, stats.mode, because this stat we have to sort the data first, but the display does not show you how this data has been sorted, right? Uh, this data is actually, because this A, right, it has been in ascending order, so you can get the modes result directly. But if it's not in ascending order, um, if it's not in ascending order, so these codings will be sort that part and find out what is the frequency for each data, right? Then this one we have mode as 3, because the frequency is 2. Count here refer to the frequency, okay, frequency of the data. Okay, after we compute that values, right? So we need to compare on which situation, because in this central tendency, measure of central tendency, um, we the difference between the mean, median, and mode will shape into a certain figure, right? Either it is left skewed, or maybe it is normal, or it can be right skewed, right? So for the case that mean is less than median and the mode, we can have negative left skewed. Okay, if the mean less than mode and median, you can have negative left skewed also. Okay, the difference is the locations lah between the mode and median, right? Positive skewed means that positive right skewed, we have median less than the mean and the mode. That means the mode is the highest, right? Another case, you can have median less than a mode and also less than the mean. So this is the meaning for each data, right? This is a specific case that you can have it, all right? And then if the mode is less than median and the mean, this show that the distribution has positively skewed or the right skewed, okay? Or if the mode is less than the mean and the median, and if we can call it as negative left skewed. If it's equal, means that it is perfect, or we can call it has symmetric distributions, or sometimes we can call it as normal distributions. Okay, so to get perfect case, if it's the data is real, it is very difficult. Usually we don't have perfect data that will give us the value of the mode equal to the median and also to the mean. Right. Okay. In terms of measures of variability, okay, we have two measures in terms of standard deviations and the variance. So to compute, we can use np.std in brackets followed by the variable mean, and then for the variable, for the variance, you can compute based on np.var in brackets and followed by the name of the variable. So in this standard deviation, what is the means? It measures the dispersions of the data point. Okay, so means that how big is the difference between uh, the lowest to the largest, or maybe lowest to the other variables. Okay, in this uh, hands-on number 3, hands-on number 3a, okay, let's try with employee data.csv. We will try to compute the mean. Okay, we try to compute the mean. Employee data, so previous data you can close it. Sorry, is it employee? Yeah, employee. Right. See here, first one is observe. Alright, so this one you can try your own first one. We start with importing the pandas, and then we have to load the data sets, check the details for the data, right? So we have 100 samples, right? And this is the correct data types. Okay, age is the integer, right? Department is the object, salary is the integer start, and then check the first few data, see here, and then you can proceed with the if now, right? And then see for all if you want to display all, can recall back the previous informations, right? um, Basically we can conclude that we do not have any pre-processing method because the data is completed, no need to do anything, right? And then we can start directly compute the means, right? Okay, compute the mean. Okay, this coding I will share with you. Okay, I will share with you in the chat section. Right, we have mean, median, and the mode. Okay, so I'll give you a few times on. Okay, try read the data and do some data exploration to see the details inside the data. All right, so this is the process. Once you compute the means, right? So this is a computed value, right? Then we have median. Okay, we have the modes. Then we have the standard deviations. Now we need to compare between this value of the means, medians, modes, right? So in terms of central tendency, yeah, right? The mean salary is 78,000 something, and then the median is 79,000 something. Uh, so quite close lah, right? Not really close lah, but it's quite close because the mean and the median we can say it is fairly symmetric distributions lah between these two. Okay, but for the modes, right, modes is less than this mean and the median, right? Less than, so quite low, 40,000 something. So because this is the mode, so mode means what? Common salary, right? So this means that the distribution include high salary, okay, that um, increase the means, okay. So in terms of standard deviations, 22,000, right? 22,000 is we can say this uh, is a big value lah, right? Is a big value because standard deviation means the difference, right? How these uh, standard deviations or the difference between that data with the means um, and the modes. So this quite, because this is quite big, so you can say this is what range of salary. So there is substantial variability in what employees earn, okay, because this is a big values. If we compare, maybe if it's 5,000, no, it's okay, right? So that is the meaning of standard deviations. Okay, because the mean and the median close, right, very close together, so we can say it is balanced and equitable salary structure. But what happens if we include the mode in the comparison? So because the mode means that common salary, right? So between the mean or the average with the presence of substantial, okay, number of lower paid employees. However, there is higher salary increase, the overall average or the means. Okay, and in terms of standard deviation, because the value is a big value, so we can say it is significant variability. Okay, so there is diverse range of pay likely due to the roles. Okay, maybe because we don't have any much information from about the data. Okay, so however, we can say that there is a potential unjustified disparities due to these uh, standard deviations value. Okay, so that is the comparisons that we can find out after we compute the value of the mean, median, and mode, and also the standard deviations, right? Okay, so any questions that you want to ask about this basic concept? Okay, let me know, please let me know. Okay, any questions about the previous basic concept and also the hands-on? No questions? Okay, is there any questions? Any questions from you guys? No questions, huh? No. No questions? How about this? Alright, shall we take break for a while? How about 8 minutes break? Do you mind? 8 minutes break? We will proceed with regressions and hypothesis testing. Right. We will resume back at 4:05. 4:05. Okay? Okay, we resume back at 405. Okay. Right, so shall we start? Okay, so we proceed to this. Okay, it's on this regressions analysis. Okay, if we already find out there is a correlations um exists, right, and the correlation is quite strong. Okay, either it has a strong positive correlation, or it can be strong negative correlations. So we can proceed with this regression analysis to find out further about the relationship. Okay, so usually the researcher will check first, is there any correlations between the variables. Okay, you can investigate for all variables, or you can investigate at the certain number of variables. Then if we find out what is the variables that you can investigate further in depth, so we can proceed with this regressions analysis, right? So this method will show us how the dependent variable, which is the x variable, sorry, the y variable change with the independent variable, which is the x. Right, so there are several types of regression analysis. Linear means relationship, okay, linear relationship between two variables. If we have more than two variables, then it is called as the multiple regression. Okay, so in these multiple regressions, we will have only one dependent variable, but there is multiple independence. That means that we have only one y variable and we have more than one x variable. Okay, if it's not as a linear, we can call that relationship as the polynomial regressions. So this is relationship that non-linear, so we can investigate further by using polynomial equations. But we will try for the first method. If we have enough time, we can proceed with these multiple regressions. All right. Okay, so let's find out. In this regression analysis, we need to import this library stats models. Okay, because we need to use that stats for the OLS, right? For the ordinary least square method as, and just to remind again, what is the meaning of the dependent variable? Right? This is y refer to the outcome that we want to predict, right, or explain. And then we have independent, which is the x, or we can call this the variable that we cannot control, or the predictor. Okay, sometimes we can call it as the explanatory variable. Then this regression analysis is actually quite close with the straight line equation. Okay, y equal to mx plus c. So in this regression analysis, there is a regression coefficients. So this coefficients is your measure the change in y variable for a unit change in x. Okay, so that is the regression coefficient. And we have intercept. This is the expected mean value of y when we have all x value is equal to 0, and then that is r squared. So r squared is actually comes from the ordinary least square methods. That means the proportions of the variance for y that explained by x. Right, so we will try this hands-on uh, for this linear relationship between the size of housing data, right? The size of the house and the price of the house. Okay, next, let's try to process the housing data, and then you go to the uh, Jupyter Lab and then open the new notebook, right? Okay, so this is actually uh, the files that I have tried before this, right? So don't worry, you can see here. Okay, so as usual, we have to import whatever required library for this task, and then we need to read the data. Okay, the data that we should read is this housing underscore data.csv. And then you can see uh, by displaying first few rows in the data sets, basically the data is completed. Okay, there's no issues with missing or duplications issue, right? And then we conduct exploratory data analysis. We'll try with the scatter plot, right, to see how is the distributions of the data, and then we will see the correlations value, right? Okay, so this is the outcome, right? So this is the scatter plot, right? It's this figure, the graph looks like or close to a linear relationship, because we can see that when the size of the house in square feet, when it is increased, right, when the size is increased, same goes to the price is also increased. So there is a relationship. We can see that this based on our observations, right? When we look at this graph based on our observations, uh, so there is a linear relationship, okay, due to the reasons when the size of the house is increased, so the price of the house also will be increased. All right, so that is the result that we have from the graph. And then we see the correlation matrix. When we compute, then this is the value, this is correlation. See that this value is between -1 to 1. Then we have this heat map, right? So the one that we're interested is this blue one, this blue one. So the correlations that we can get here is close to 0.99, almost perfect, right? Almost perfect. So this is very strong positive correlation, okay? Strong positive, right? Okay, so due to this reason, due to this correlation value, then we proceed with these regressions, right? Okay, so for these regressions, right? For this regression, okay, uh, for these regressions, first one, we need to specify which variable is your x and y. Okay, yeah, so you need to define which one is the x and y. And then there is a constant, because in this correlation, in the regression, there is a coefficient, right? Okay, and then you need to add the constants using this part. Okay, and then we need to fit the data to the model of the regression. Okay, so we have to use this part. So this OLS refer to your ordinary least square, right? So it will be y followed by x. Y is the dependent and x is independent. Then fit the data to this regression model, and then you have to print this model, right? So this is the result of the regressions. Okay, this is the result. This is actually quite close to the statistical result. So this r squared is the part that we are interested for. And then you can see now what is the model. This is a regression. If we have different model, then this model in this table might be a different one, not as OLS. It will be a different name. Okay. Okay, so from these tables, we can figure out more about the model that we should write as the regressions model. Okay, let's say we want to figure what is the equation that represent this model, right? So you can use this one, extract the coefficients from this model. Okay, that means from the above table. Okay, so we have uh, the gradient value. Okay, assume that this regression is quite close to your um, straight line equations, right? Okay, equation of straight line. So the gradient will be you can get from this table. Okay, this is the coefficients of the size gradient. So this is the gradient value. So x is your independent variable, right? And then your coefficients, which is the y-intercepts. Okay, you can find out from this table. Yeah. Okay, this one coefficients, but it's not represented properly because this is written in the exponents symbols. This is actually the value, but we can extract it, right? So then we have this part. This is the intercept at y-axis. Okay, so we can predict the dependent, which is the price. We can predict the price based on this model, right? So this is the gradient, and then this is your x variable, and then this is the intercept at y-axis. Okay, so to extract the coefficients, we are using these kinds of codes. Okay, the intercept comes from the OLS model, which is from the above with the parameters which is 0, and then the slope as the model from the parameters which is 1, right? And then we can write it down as the equation using regression equations. Okay, functions. Okay, so if we want to predict, let's say from the data, okay, as let's say if we have the price of 35, sorry, if we have the house of the price as 350,000, so what is the size? So this is one situation that we can do the predictions, right? Okay, so to predict, so we can set in the proper way. So the method to predict the price with a given size of the house as the input, you can create one functions. Okay, one functions. So these functions we can call as user defined functions with argument. Okay, with arguments. This is there is an input here. So we have size here. So this function is to predict the price of the house, and then we have second function to predict the size with the given input price, right? Okay, then this is the task that is we are supposed to return the intercept plus with the slope times with the size. So this is actually the formula in order to predict the price. Okay, you see this formula is different with the second formula because the second formula here is to predict the size, not the same with the above. Okay, so with a specific given input, so you can set lah what is the size. Let's say the size that we want to check is 2,400. Then, so what is the value of the predicted price? Now, if the price of the house, let's say maybe 300,000, or you can change to other values, then you can say what is the computed, sorry, what is the predicted value of the house of the price house, right? Okay, using this kinds of process. Okay, so this computed value, if the predicted price for size is 2,400, then this is the predicted price. And if the price is 300,000, then this is the predicted size. Okay, so that is the meaning for this regressions analysis. Okay. Okay, so that this is the OLS regressions result. In this part, do you have any question to ask for this regression? Any question to ask? Alright, for the code, right, I already upload for 3A. Okay, for the code, yeah, but 3A. Wait a minute, give me time. Okay, for 3B, yeah, I will upload now. Yeah, give me a time. Okay, done now. I'll upload for 3B. Can you check? It's in the Google Drive link. Let me know if you couldn't see. If you couldn't see the file, let me know. All right. Okay. Yeah. Okay. Can we proceed? All right. Let's see. Next one is actually is the hypothesis testing. But let me introduce a bit what is the probability distributions that we work with this hypothesis testing. Okay, so hypothesis testing required probability distributions from continuous type. Okay, so in statistic we have several types of probability distributions. Basically, uh, relies on the types of variable. Let's say if we have discrete variable, then we can use discrete probability distribution such as the binomial or the Poisson. Okay, to solve that problem. Okay, but for the continuous quantitative variable, we can relies on this normal distribution. Okay, so hypothesis testing require these normal distributions. What is the normal distributions? Right. So from the figure on the graph, so that is the normal curve, right? So this normal curve we call as the normal distributions, the curve that follow the normal distribution concept. So these normal probability distributions characterized by this curve of bell shape, right? And defined by the mean and also the standard deviation. In this case, the mean is equal to the median and also equal to the mode. But what is the interest of this situation is the means and also the value of standard deviations. Um, for this normal probability distribution, there is a function that we call as density function of a normal distribution, which is given by this equation. Okay, so in this case, we have x refer to your continuous quantitative variables, right? So manually, we can realize on this probability function and we can compute the computations based on the shaded regions on the normal curve, right? So in order to do the hypothesis testing, right, we will apply this normal probability distribution. So this is required in the hypothesis testing because in the hypothesis testing, there are several methods such as Z-test and also t-test, okay, and we can consider also for the analysis of variance, which is the ANOVA. So in this Z-test method, one of the hypothesis methods will be applicable when we have sample size that is large and also when the populations of the standard deviation is known. If it's based on the t-test method, okay, we will use this based on the sample size which is small and when the standard deviation is unknown. So we can consider there is some approximation the normal deviation as the sample size increase. Okay, for the analysis of variance, we will assume that the residuals, in other words, the error for that case of the model are normally distributed. Okay, this is the summarized steps in the hypothesis testing. Okay, so in this hypothesis testing, uh, this is something like when we cannot figure out more details on the distributions of the data, and then we need to proceed with some non-graphical method to conduct further statistical analysis, right, or data analysis. Okay, so this is one of them, which is this is one of the method of non-graphical data analysis. And the first step involved in this hypothesis testing is to formulate the hypothesis. There are two types of hypothesis, which is the null and also alternative. Okay, so the null will be written as this H naught. Okay, the alternative will be written as H1. Sometimes they use HA. Okay, Either you want to use H1 or HA, depends on the choice. Null hypothesis refer to the statements or something that we want to formulate in terms of maybe uh, the populate based on the mean or the average, or it can be based on the standard deviations. And this null hypothesis is developed based on no effect or difference. Okay, and then alternative hypothesis, we have an effect or difference. For example, right, in this null hypothesis, we have the mean salary of employees, which is equal to $50,000, right? So this one is not effect or difference, right? So this one is, we can say that this is mu, okay, equal to 50,000, right? Equal to, so no effect or difference, right? For the alternative hypothesis, which is H1, right? It is not equal, okay? So if it's not equal, so we just use this one, not equal. That means there is a difference. So that's why we have H1 as mu that is not equal to. We can have others, let's say not we can have others such as greater than, or it can be less than. That is also represent um, the effect or the difference, right? So we cannot say that the null hypothesis which is not equal to, because there is an effect. So something that is an effect or difference should not be the null hypothesis. It should be as alternative hypothesis. Right. Before we proceed to the steps, the second steps, this is something that you need to know. There is two types of errors in hypothesis testing. First one is type 1 error. This is error that might happen when we are supposed to reject uh, the true null hypothesis, but it's actually false positive, right? Reject true null hypothesis, but we accept it. So this is false positive, right? Okay, so excuse me. This type 1 error we call as alpha. Okay. Type 2 error is the case when we fail to reject. That means we accept the null hypothesis, okay, but it's not true. Okay, we accept the null hypothesis, but actually it's not true. So we can call we accept a false null hypothesis. Okay, so we can say it is false negative, but we accept it. So this type 2 error we call as the beta value. So in statistical hypothesis, the meaning of alpha and beta based on these two types of error, right? And then p-value and the significant levels is based on the alpha value, right? So p-value is the probability of observing the data but assume the null hypothesis is true. So p-value is something that we can compare it later. And then for the significance level, which is denoted by alpha, it is threshold for rejecting the null hypothesis, commonly used as 0.05. Sometimes will be represented as 5%. Okay, so in the previous step one is formulate the hypothesis, right? So either you can formulate the hypothesis, or at least you know what is the statement that represent the null and also alternative hypothesis. For a second step, we need to choose appropriate test. Okay, so there are several tests. So t-test is the first one that can be used if we want to compare the means value between two groups, right? These include the independent t-test or pair t-test. In one hypothesis testing, you can only choose one based on the um, issues, whether you want to compare means between groups or compare means across three groups or so on. Okay, there is a difference while applying or choose appropriate tests in the hypothesis testing. Right, for independent t-test, we can use this method if we want to compare means between two independent groups. And for the paired t-test, we can use this method in the case that comparing means within the same group at different times. Okay, for this ANOVA, we'll use this analysis of variance to compare means across three, or it can be bigger than that. Okay, that means more than uh, as expected one. Okay, and then for next method we can use chi-square test. So this chi-square test used for categorical data. Okay, chi-square if we want to conduct the analysis. So based on hypothesis testing, if the variable is categorical data, so we can use chi-square test. So in this method, we can assess how the observed distributions is due to the chance. And then for the z-test, it will be applicable if we have large sample size. Okay, in that case, and then we can compare the computed value between your sample and also population means, or it can be in terms of proportions. For the proportion test, this method will be useful when we want to compare proportions between two groups. Okay, so the third step is we will compute the test statistic. Okay, compute the test statistic based on which method that we want to apply in the methods, or which one is suitable to be applied. Okay, if we want to t-test, so that means compute test statistic based on t-test, or compute test statistic based on the z-test, or it can be compute test statistic based on ANOVA. All right. So this test statistic is standardized value that is computed from sample data during the hypothesis testing, right? And we have different formulations to follow, but in the uh, computations of the test statistic, we need to include this one from stats model dot stats proportions import proportion z test. For example, this one, if we want to apply z test in the problem, if we have other method that we want to use which is not the z test, then you have to use the corresponding one lah. Alright, okay, next one. Once we have the test statistic value, we need to find out what is the p-value in that situations. Okay, so what is the p-value? So it means the probability that the observed data would occur if the null hypothesis is true. Okay, so in order to determine the p-value, we look at the value itself, either it is a low value or the high value. Low p-value if it's less than the alpha. Okay, that means there is a strong evidence against the null hypothesis. So this will lead to the rejection. Okay, for high p-value, when we have the case that the p-value is greater than alpha, this shows there is a weak evidence against the null hypothesis, right? So this will leads to the acceptance of the null hypothesis. Okay, so after we determine the p-value, so what next? We are supposed to state the decisions. So before that, we have to compare the p-value with the alpha. Okay, so commonly use alpha as 0.05, but we can have different situations. If it's not 0.05, it will be mentioned in the problem. Right, so in the decisions, there are two types of decisions that you can choose only. First one is the rejection, second one is accept it. Okay, not reject. So in this reject null hypothesis, so when is the case that we will reject? So if the p-value is less than or equal to alpha, okay, so we will reject the null hypothesis, indicate a significant result. Okay, if the p-value is greater than alpha, that means there is no significant result. Okay, so that so what will happen? We are supposed to accept the null hypothesis, right? So previously we have reject, and also we have accept. The concern is on the null hypothesis. Okay, that is the main concern. What will happen to the null hypothesis? Either we will reject or we will accept it. Okay, so once we identify, let's say we have reject, we need to reject. Okay, so we have evidence, we have statistical evidence that this is the decision that we should reject, and then we need to report what is the decisions, okay, through the conclusions, right? So the conclusion should be stated in the context of original hypothesis and the data. So we need to report what is the test statistic value or maybe p value at a certain significant level, right? Okay, so in this case, we will try hands-on, next hands-on on this hypothesis testing on the marketing campaign, right? Marketing campaign. Right, so see the marketing campaign. Hmm. Give me time. Okay, marketing campaign. Okay, we have only two variables: campaigns, which is the categorical, and this conversions. Conversions 0 and 1. Right? Okay, so we need to conduct the hypothesis testing to analyze the marketing campaign, and we supposed to help the CEO to decide which campaign can be chosen, right? Okay, so by following the previous steps, so we'll start with the hypothesis uh, formulations in terms of the null and also the alternative hypothesis. Now, what is the issues here? We have this following problem statement. In this hands-on 3D, we need to check if there's a significant difference in the conversion rate between two marketing campaigns, right? So the null hypothesis is the conversion rate for campaigns A and B are equal. Okay, that is are equal. It's important one. And then for alternative hypothesis, conversion rate for the campaigns are different. Okay. Second step, we need to use we need to decide which method suitable one. So we use two proportion Z test, right? Two proportion means that we have two tails to compare the conversion rate between the two campaigns, right? And then we will compute the test statistic, right? Test statistic. So in this hypothesis testing, we need to include the stat models because this one is under Z-test method, so that import proportion Z-test should be included. Alright, so okay, in our campaign we can see that the campaign is the one of the variable is the types, right? Categorical. So we need to convert the number of conventions and the total number of the counts, and then perform the two proportions of Z-test, or means that means that is Z-test hypothesis testing methods, and then see what is the value, right? Okay, so this is the important parts. We will see after this in this codes. Okay, this hands-on 3D. I will share the codes. I want you to try because it is something that you need to try. Okay, you are supposed to create new files. So let me share the codes. Right? Share the codes here. Okay, can create new files for this hands-on 3D and see whether you got the same values or not. Okay. Okay, try. Let me know if you got the same value or not. Okay, we will. You have to do. You have to do some assignments later after this. So make sure you got clear understandings for this part. Okay. So once we compute the test statistic, right, then we compare with the p-value, right? So the test statistic is 1.0224, right? The p-value is 0.30658, right? So the next step we need to do comparison. Okay. So how to decide we are supposed to reject or accept the null hypothesis. Okay, so as explained before this, that we will reject on certain cases if we have to accept on certain case, right? In this Z test, we compare the p-value and also the one that we computed, which is the stat. So p-value we have here 0.307, right? We know that in this case, by default, this is common significance level, which is 0.05 or 5%. Okay, so if we compare that p-value with this alpha, of course 0.307 is greater than, am I right? Okay, because this p-value is greater than the significant level, which is alpha, and then so we are supposed to uh, accept the null hypothesis. Okay, accepts. Okay, that means we are not going to reject the null hypothesis. Right, so we have to report the results. Okay, so what kinds of result? They in this hypothesis testing, you must have a proper conclusions, right? Uh, so the computed value is your statistical evidence. It is very important one. Okay, so from the data and the result that we have in this statistic are also based on the p-value, because the p-value is greater than your alpha, so we conclude there is no statistically significant difference in the conversion rate, okay, between the campaigns A and B, okay, at the 5% significant level. So in the decisions, this result reporting is very important, must includes what is the value of the significance level, because there is a different way. You can include based on the 5% or maybe 1%. So in terms of decision making statement, this significance level percentage should be stated. Okay, so due to this decision, so what happened next, right? Okay, because we know already that we find out there's no significant difference in the conversion rate between the marketing campaigns. So we can say that both campaigns have a similar performance in terms of the conversion rate. Okay, this one should reflect back to the step number one lah, right? So what is the step number one? Okay, step number one, conversion rate for campaigns are equal, right? Step number null hypothesis stated that the conversion rate for campaigns A and B are equal. Okay, alternative hypothesis states that the conversion rate for the campaigns A and B are different, right? So that is the uh, we can suggest or recommend that both campaigns have um, similar performance in terms of conversion rates. So this is a direct result when we accept the null hypothesis. Okay, right. Any questions that you want to ask about this hypothesis testing? Questions? Is there anything you want to ask? Okay. Right. It is a part only. Code incomplete. Yeah, yeah, wait. Share something. Code incomplete. Yeah, it's done already. So that is p-value. Which one you don't have it? I think it's done already. So it's done. I think I already copy all. Which one you don't get? Sorry, Yongyi? I copy until start and the p-value, right? Do you miss anything, Yongyi? Cut off at the... Oh, right. Sorry. Cut off at the end. At the end. Okay. Okay. Maybe due to... Maybe it's wrong. Let me post it back. Alright. Sorry. It's the same code. Yeah. Let me copy part by part. Okay. First part. I already posted first part. Uh, we have second part. Maybe it's too long. That's why it's cut off. Okay. Thank you for the feedback. Right. Thank you for the feedback. Okay. You have tried the codes. Is it okay? Alright. Okay. Is it okay? Okay, before we start the projects, I'll give you some problem for you to try. Right? Okay, let's see what you have learned so far on this part. Okay, let's let's try to answer the following questions. And the first three questions you can post the answer. What is your answer? Maybe A, B, C. So just post A, B, C. Okay, A for the first answer, B for the second, third, C is for the third one. Okay, for examples. Okay, C. Right, so just answer, just type your answer. Okay, let me see what's your answer for the first three questions. Can you type your answer? Can you type your answer? First three questions, what's your answer? BCP, right, correct. Okay, it's correct, BCP. Right, so what is the primary goal of data analytics? Okay, correct answer is B, right? This is the best answer, to analyze raw data and make conclusions about the informations. Number two, which of the following is not a component of data analytics? Say, answer is C, that not a component, right? Then data analytics is essential for making data driven decisions. Right. Okay, now let's see next questions. Okay, you can type your answer for these questions 4, 5, 6. All right, so let's see your answer. Can you type your answers? So what's your answer? See what's your answer there? CBA. Let's see answers from others. CBC, BDA, CBC, BAA. Okay. Uh, okay, what is the first step in the analytics life cycle? Identifying the problems. Right. So, which of the following is common myth about data analysis, right? Okay, data alone has its meaning. This is common myth, right? Data alone has its meaning. Not true. I mean, it is true that it is common myth. Analysis comes after all the data collected. This is also common myth. All right. Most people appreciate practical analysis, right? This is also common myth. right? All analysis have weaknesses. Okay, this is also common myth. Okay, so for this question 5, this is all the common myth about data analysis. Right. For number 6, which type of data refers to descriptive or categorical data? Right, descriptive categorical is based on qualitative variables. Right. Okay, so this is the last 4 questions. I will show this 7 and 9, and then I will proceed the last questions. Okay, so for this last answer, you are supposed to answer 4 questions. That's 4 questions. I will show you questions number 10 after this. Right, then this is the last questions. Okay, so let's see what's your answer. See what's your answer for the last 4 questions. What's your answer for the last 4? CBAC. Alright, how about this? Okay, what types of chart is used to show the proportions of classes for categorical variables? Answers is pie chart. Okay. Uh, which tool is described as versatile programming language, ideal for data analysis? Okay, this is a Python. And then what is the term um, for a hypothesis that states there is no effect or difference? Should be null hypothesis, right? And then what visualizations technique is used to show the correlations between numerical variables using color codes? Right, so answer is heat map. Okay, so answer is heat map. Okay, so these last questions are not confused because I think in the previous slides we have correlations value whereby the categorical data we convert to numerical values, right? So once we converted that categorical variables to the numerical codes, then we assume that um, the variable is now being defined as numerical variables. So we can proceed with this heat map in the visualization method lah. Okay, so that's the meaning of numerical variables. uh, we can convert the categorical variable or qualitative variables to the numerical variables. Then we can conduct the correlations to show what is the heat map between um, the correlations value between the variables involved in the data, right? Okay. mm, all right, so this is the project that you are supposed to try. So yeah, this one. Okay, you are supposed to try. Okay, you are supposed to answer it, right? This project involve you need to use this online retail sales data set, right, and perform a comprehensive data analysis, right? You are supposed to check if there is any data cleaning required. Let's say if there's any missing value or duplications, right? And you have to prepare the data. Once the data is being completed, then you can proceed with exploratory data analysis, right? And then uh, conduct the statistical analysis and provide your conclusions in the report. Okay, so in the data sets, it contains transaction ID, the product ID, the product descriptions, okay, quantity purchase, and then purchase date, customer ID, and also price for the product. Okay, so this price will be price per unit lah, right? Okay, so let's see the data is online retail sales. Right, this data is not very big lah, right? Now we observe this transactions ID, what is the type, this product ID, okay, product descriptions, the number of quantity purchased, the purchase dates. You have to scroll to the right, we got some other attributes, which is the customer ID, okay, and the price. Okay, so by using this data, first one, you need to check the details for this data. Look at, is there any data is missing, duplications. So we need to decide what we are supposed to do, right? Okay, so you can create this project. Create new files for these assignments, and then conduct as guided in the task lah, right? Okay, so you can do until I think 5:30. Is it okay? You think you can have you can complete that? Do you think is it okay until 5:30? Okay, until 5:30, is it okay, Okay, once you're done, you can save the files as PDF, and then uh, you can submit in the following link. I posted that one for the submissions. Okay, so I will give some tips for you to handle. After you load the data sets, you can check any missing values on the data, right? So find out lah if there's any missing values on your data sets. Okay, let's say product description is missing, or maybe the customer ID is missing. So what you are supposed to do? Okay, so this missing, what we can do to replace lah. Maybe for the product descriptions. Okay, maybe product description, if it's not important, you can fill in with these unknowns, right? Unknown product, because this product descriptions, right, is we cannot we can't mention. Maybe uh, some item does not included in the list or in the record, so we cannot fill in with the modes and so on lah. So we can replace it with the unknowns. Okay, for the customer ID, this customer ID we can replace it with the mode, because this customer ID is the one who is maybe buying that product. So as the retail sales, so maybe this customer ID, when this ID is missing, so we can replace it with the ID of the customer who is frequently buy that product. So we will replace that any missing customer ID with the mode. Okay, so that is the way how we handle the missing values, right? And then you can continue with the duplicates, check, and then if there's any data types that you need to correct, like previous case, we change or do corrections on the data types based on the maybe the dates, we revise it to the two date time, right? So revise it, and then um, you need to prepare the data. Maybe it is something that you have to do computations, right? Okay, and then conduct maybe analysis based on, first one we start with univariate analysis. We want to investigate at the single variable, right? Okay, so at first we do univariate analysis, we conduct histogram. So maybe you can use histogram for the quantity purchase. See what is the distribution, right? So that is first univariate analysis, right? Histogram based on the quantity purchased. And then you can have box plot for that quantity purchased. See what is the result. Okay, for the um, bivariate analysis, this is between two variables, right? You can use scatter plot, maybe between the price against the quantity purchased. Okay, so use the scatter plot for the price and the quantity purchased. Right, and then you can use heat map, right? Heat map for all variables, or and then find out what is the relationship. And then in the descriptive analysis, once you've done that, is the exploratory, right? And then we proceed with the basic statistical concepts, such as we compute the mean for the quantity purchased, we compute the median for the quantity purchased, and then find out what is the mean. Then we compare what is the standard deviations, right? uh, so when we want to compare the mean, median, and mode, you can do similar conclusions like what we have in the slides, right? So if this mean is less than the mode and median, so what is that means? So that is something that you need to status lah in the findings, right? And then you can perform maybe Z test or maybe T test process. You need to status lah what is your hypothesis testing that you want to investigate, right? Okay, if in the previous exploratory, when you find out there is a correlation value, maybe there is a correlation between the price and the quantity purchased, right? Okay. Right, so the price, let's say it is X variables, all right, the price of the item, and then the quantity purchased is the Y. So you can comes up maybe with the linear regression, so and then find out what is the model to see the relationships, right? uh, Between these two variables, and then you have to summarize result. Okay, you have to summarize the result. So it looks like quite long, but actually you are doing steps by step at different phase, right? Okay, so see what is the purchase behavior, price influence, and then is there any trends, and then is there any outliers occurred in the data, so you can find out, right? Okay, so outliers will exist in the box plot lah. If there is outlier, you can find it out, right? Okay, so you can try, please let me know if you need anything. If you have problems, you start, you just let me know. Alright, do you need more time to do that? Do you need more time? Alright, alright. I'll give you extra 10 minutes, okay? Extra 10 minutes. Maybe until 5:40. Okay, until 5:40, yeah. All right, I will discuss how to do that one. All right. Okay. So first one, we have to import the files, important files. Okay. Let's start with pandas. Because we have lots of analysis that we need to conduct, right? So these are all the important library files, and also the uh, science Python that we need to import reads for the stats, and then we need to read the data. Okay, so using this pd.read csv, and then first one we check infos. Good. For this info, right? um, We have transactions ID, product ID, the descriptions, the quantity purchase, purchase date, and the customer ID, and also the price. So price is okay in the correct data type. But for this purchase dates, right, it is object. So object refer to the categorical variable. But in case that we want to extract the data from this date, right? So purchase date, maybe if you want to extract the month. Okay, so that kinds of data type should not be is an object lah, because it's categorical. So we need to change this data type into date time. Okay, if you want to extract it, so you have to convert this purchase date to date time, so that we can extract some informations from this purchase date, right? And then we check from the missing values, right, using this is now, and this is the result. And then we will begin with uh, correcting the data types for this purchase date. Okay, so purchase date just now is the object type, so we can change it to this, to date time, right? And then once we correcting this one, you have to recheck again lah. So go to this dot info, right? Now you see that this purchase date has been changed lah. Just now is object type, right? Now it's changed to date time. Okay, this is the format date time, so that we can extract it the data after this. Okay, so in case if there's a duplications, because duplications we can see, cannot see from the is null coding, so you can just to double check, so you can drop any duplications, right? So in this case, right, for this numerical, I will do normalizations for the numerical data, right? The attribute is about this price. Okay, normalization, which it's something that we want to change some values to contribute to a new items. The formula will be the difference between this price data frame, and then we want to find out the mean, and then we divide with the difference between the maximum with the mean. So basically this is divide by the range lah, so that is the normalizations. Okay, uh since we have changed data types for the purchase date, right, and then I want to extract the month and the year from the purchase date. So just now we have converted it into date time format, right? So this is the way how we can extract. So will be months, extract months from the purchase date, and then dot dt. Okay, and then year, extract year from the purchase date, then dot dt dot year. Okay, so you can proceed with the details, check for any maybe for the ilog to see all the details inside. Okay, you can review all using ilog location to see all of them, and then we will start by earlier descriptions on this analysis based on single variable. Okay, or we can call it as univariate analysis. Right, so I want to see the distributions between I want to see the distribution, because this is single variable, right? I want to see on the quantity purchase, and also um, the box plot. Okay, based on the histogram and the box plot. So actually one of them is also enough. So let's see, this is the result for the histogram, right? Okay, this is the number of items. Can see the gaps here, right? These items 4. So the these items 4 and 6 are okay. Noted the number of quantity purchased, right? Is then on the y-axis is the frequency. Okay, so that is the earlier investigations that we can do. So we can use box plot also. And this is the result, right? Okay, so this is actually equally, right? We don't see any gaps too much on this one. And then we conduct analysis between two variables. The most important part here, we want to check the price and also the quantity purchased, right? So we will review the analysis based on the scatter plot. Okay, this is the earliest distributions. So all the data will be plotted in the scatter, and then we see x is the price, y is the quantity purchased, right? And then this is the result that we have. Okay, this is the distributions. Looks like difficult to see, right? Okay, then we proceed with this heat map. Okay, the heat map for all variables. This is heat map for all variables, and then this is the result. Okay, the important part is the value of the correlations. Let's see here. We have between the transactions ID with the product ID. Okay, it's a week lah. So between transactions ID and also the quantity purchase has got these kinds of correlations. Okay, the one that we want to check, okay, others is between transactions ID and customer ID. It's the same thing, right? Weak, and then this one also very weak because it's close to zero. This is close to negative 0.1. Quite weak also, but this is negative weak correlations, right? Then this is positive weak correlations. Okay. Okay, what's the result that we can investigate is for the all one, for the all variables, we can proceed with multivariate analysis, right? Okay, this multivariate analysis is under pair plot. Okay, this is under pair plot. So you can investigate between the price, quantity purchase, and the month. Okay, so the price, quantity purchase, and the month. So this is more than one variable. Okay, see, price, quantity purchase. Uh, hmm, right. So the price and quantity purchase. Okay, so this color, price and the quantity purchase, this kinds of color would be like this one. Okay, and then the month, maybe price and the month, this price and the month. Okay, more close to zero, right? Okay, so we do multivariate analysis to see the plot. This just to see the distributions between these three variables. Okay, this is not an in-depth analysis, right? So we got these patterns. Uh, they show these kinds of methods show us about the histogram, and also uh, the bubble chart, or looks like bubble chart, or maybe this is a scatter plot. So this multivariate, they pair the graph based on two types. Okay, so this is the pair plot methods, right? Okay, this is just for the distributions of the data between those three variables. Okay, and then we proceed with basic concepts such as we compute the mean, the median, and the modes, and also the standard deviations. We are conscious about the number of quantity purchased, right? Okay, so we are not consider whatever the categorical variables that is exist in the data sets. Then for this basic statistic, mean, median, mode, and also standard deviations only applicable for numerical variables. Okay, then we compute the mean, median, mode, and also standard deviations, right? And then see what's the result. Okay, so we compare. We can proceed by comparing the median, mean, and modes, like previous hands-on, right? And then we conduct hypothesis testing, right? For this hypothesis testing, so we have start with step one. So null hypothesis, there's no difference in quantity purchased before and after 2020, for examples, and then the alternative hypothesis, there is a difference in the quantity purchased before and after year 2020, right? Okay, so in this case, we need to create the period column. So this is something that it is um, additional task that we are supposed to do to create a column for before and after 2020, right? So we create a column periods whereby using the numpy, okay, where this year is less than 2020, then we set it as before and after 2020. Okay, then we choose hypothesis testing. You can replace this one I try with t-test. Okay, you can replace with z-test actually, but at the end the decision should be the same, except that the methods that we apply in the hypothesis testing is different, right? So for this hypothesis testing, I'm using t-test, and then I'll decide to investigate um, the test value between this start for the year before 2020 and also after 2020, and then we compare the t statistic and the p value, right? So the results show um, we have test statistic 1.10, we have p value 0.27, right? Okay, so what is the outcome from this hypothesis testing? Is it uh, reject the null hypothesis or accept the null hypothesis, right? So are we supposed to reject or not? Okay, this case will be based on the slides. You see whether this is this p value, is it greater than the alpha or less than the alpha, right? By assumptions, this heightens the library of this hypothesis testing will be by standard is 0.05, right? Right, in terms of regressions analysis, we can use linear regressions between two variables only. Okay, but this is optional, not compulsory. Uh, I would say in terms of hypothesis testing, this one is might be better or in-depth analysis. But for regressions analysis, if it's linear, we only can investigate between two variables, right? Let's say x is the price and y is the quantity purchased, right? And then we want to see the model, right? So the model you can get from the displayed here, the coefficients of the interceptions, and then we write down the model into the regressions or best fit line model. Okay, okay, so that is the guidelines about this one. You can sort it properly and then complete some kinds of analysis, right? Is there any question you want to ask? I will share the codes in the drive. So just now I already upload the hands-on. Hopefully nothing is missing, right? Any questions? Is there any questions? All right, any question, guys? Any questions? No questions, I assume everything is okay, No questions, Is everything okay? Right. All right. So I think that's all for today. Now I will pass the floor to Mandy.
Okay, so thank you everyone. And don't leave the meeting yet because I got some form to let you guys to fill in first. Okay. So yeah, here's the QR code for you to scan in and help me to fill in the post survey form for this workshop. Or you can also click the link that I post in the chat box. Okay, so after you fill in the form, then you only leave the meeting. And don't forget to say thank you to the workshop instructor today. Yeah. So you after fill in the form, then you can leave the meeting. Yeah.